Hi students, today we're looking at lessons 5.4 and 5.6. Today we're adding and subtracting decimals with base 10 blocks. Students will be able to explore adding and subtracting decimals using base 10 blocks. So please have with you today your base 10 blocks. They were given to you in the bag of materials in the beginning of the school year. They're the green foamy things. All right, so before we get into the actual adding and subtracting, I want to just go over how we're going to use the base 10 blocks when working with decimals. So when we're talking about decimal numbers, the 100ths frame that I'm holding in my hand is going to represent one whole. The tens rod that I'm holding in my hand, there's 10 equal sized squares or cubes, will represent 1/10. And then the cube, the small cube, is going to represent 1/100th. So just to review, we have representing one whole, 1/10, and 1/100th. So let's look at how we can build some decimals and then add and subtract them. Let's start off building the decimal 1 6/10. To do this, I will need one whole and then 6 of the tenths. 1, 2, 3, 4, 5, 6. So this represents one whole and 6/10. We can see that 6/10, when I lay it on top of my whole, is less than a whole. So 6/10 is part of our whole. It's not an entire whole amount. All right, let's take our 1 6/10 and add to it 13/100ths. So I moved my 1 6/10 to the bottom to give space. And now I want to show 13/100ths. When I look at 13/100ths, I have 0 wholes. In my tenths place, I have 1. So I need to bring in 1/10. In my hundredths place, I have a 3. So I need to bring in 3/100ths. So to model 13/100ths, I have 1/10 and 3/100ths. And if I counted up each little cube, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I really have a total of 13/100ths pieces, but these 10 are grouped together to show that they're equal to a tenth. So what does 1 6/10 and 13/100ths total? Well, let's bring in our 1 6/10 that we built earlier. Here's my one whole and my 6/10, and here's that 13/100ths. I'm going to start by combining the smallest unit first. Well, I only had 3/100ths, so they're not able to be combined with anything. Next, I'm going to combine that 1/10 with my 6/10. And I have 1, 2, 3, 4, 5, 6, 7 tenths. That's less than a whole still. See? When I put my 7/10 on top of my whole, I can see that it's still not a whole. It's less than a whole. So I've combined everything I can combine. So let's find our sum. I have a total of one whole. I had 7 in my tenths, and I have 3/100ths. So our sum is 1 73/100ths. Let's try another one. At home, you should be building this with me if you have your base 10 blocks. Let's try 2 9/100ths plus 0 and 64 hundredths. First, we're going to build 2 and 9 hundredths. To build that, I need 2 wholes, and I need 0 tenths. I need 9 hundredths. I'm going to stack these so I have some space. I need 9 of my little hundredths. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9. So here are 9 hundredths. 2 wholes, 9 hundredths, no tenths for that one. All right, I'm moving that to the bottom and I'm building my second amount, 0 and 64 hundredths. So in this one, I have no wholes. I have a 6 in my tenths place, which means I need 6 of my tenths rods. 1, 2, 3, 4, 5, 6. Here are 6 tenths. And I need 4 hundredths. 1, 2, 3, 4. So this shows 6 tenths, 4 hundredths, and if I counted each individual tenth, each individual part of my tenths, I'd get a total of 64 hundredths. 10, 20, 30, 40, 50, 64. So there's my 64 hundredths. Let's bring in our 2 and 9 tenths. Here's our 2 wholes, or 2 and 9 hundredths, I'm sorry. 2 and 9 hundredths. Here are my 9 hundredths. All right, to add these together, I'm going to start with my smallest place value and combine them. Let's see. I have 3, 4, 5, 6, 7, 8, 9. Here's 10. Now what I can do when I get a stack or a row of 10 of the hundredths pieces, that's actually equal or equivalent to 1/10. So 10 of the hundredths can be exchanged for a tenths piece. They're the same amount. So I brought in a new tenths piece and I'm taking out 10 of my hundredths. It's the same amount, it's just represented differently. This is like when you carry over in addition. All right, but I'm still left with these little 3 hundredths. Now I'm putting that new tenths over with my other tenths. 1, 2, 3, 4, 5, 6, 7. Now I have 7 of my tenths. Still less than a whole, so I can't combine them. And then I have my original 2 wholes. So let's find the sum. I have 2 wholes. I have 7 tenths. And I have 3 hundredths. So when I add 2 and 9 hundredths plus 64 hundredths, I get 2 and 73 hundredths. Now let's look at a subtraction problem. Let's say that we have 2.41 or 2 and 41 hundredths, and we're taking away 1 and 3 tenths. So let's build these. 2 wholes and 41 hundredths, that's 4 tenths, and 1 hundredths. So here is 2 wholes, 4 tenths, 1 hundredth. That represents 2 and 41 hundredths. Now I'm not adding anything to it. This time I'm taking away. And what am I taking away? 1 whole and 3 tenths. Starting with my smallest place value. Do I have 3 tenths to take away? Yeah, I can take away these 3 tenths. 1, 2, 3. Pull them out, get rid of them. Now let's take away that whole. Here we go. I can take away 1 whole. And what am I left with? 1 whole, 1 tenth, and 1/100th. So I'm left with 1 and 11/100ths. All right, let's do one more. I'm going to give you a little bit of a more challenging problem now. Let's take 3.2, sorry, I'm just trying to think. 3.24 minus 1.5. So let's start by building them. Oh, hold on, I don't have enough. Let's scratch that out and make that a 2. I don't have enough of the ones. So I have 2.24. 2 wholes, 2/10ths, 4/100ths. Here's my 2.24. And I need to take away 1.5. All right, so I have to end up taking away a whole and 5/10ths. Well, because this number has no hundredths, I'm actually leaving my hundredths. They're going to be a part of my answer. But when I look at my tenths, I only have 2 of the tenths rods. I need to take 5 away. So what do? I would borrow. I'm going to trade in by taking one of my wholes and changing that into the same amount, just represented differently. So how many tenths frames will fit on one of my whole pieces? Let's line them up and see how many tenths can fit on here. All right, ready? Let's count how many of the tenths. Oops, one fell off. Boop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of these tenths are the same thing as a whole, because 10/10 equals a whole. So I'm going to take out a whole to borrow, get rid of it, and in place, I have my 10/10. So it's the same exact amount, but I traded them in because now I have pieces that I can actually move apart. So I still have 2 and 24/100ths, but now I can take away 5/10ths. So I'm taking away 5 of my tenths. 1, 2, 3, 4, 5. Taking them away. And now what am I left with? Oh wait, I forgot to take away a whole. So I took away 5/10ths, but now I have to take away this extra whole. The first whole was when I traded. This whole has to go away. So what's my final answer? What's my difference? 1, 2, 3, 4, 5, 6. I have 7/10ths. No holes left. And then I have 4/100ths. So when I subtracted these, I had to borrow or regroup or exchange or trade, whatever you want to call it. And I got 74/100ths. Hope you find this helpful. We're going to be doing this skill today in class. Let me know if you have any questions, and I will see you next time. Thanks.